So, hi everyone. My name is Amir Jerbi. I'm the CTO and co-founder of Aqua Security. And today, on this session, we are going to talk about managing security at scale. And we will focus on Kubernetes, of course. So, let's start with a definition of scale. So, who knows what scale is? Raise your hand. Easy, right? In the world of Kubernetes, Docker, and containers, 4 years ago when we started, scale was an easy problem. You only had one orchestrator, you only had Docker, basically. And when people were talking about scale, it was only about the size, right? It was about whether you have 50 nodes or 5,000 nodes or maybe 50K of K nodes. Usually people will use Jenkins or whatever CI/CD tools they have. There was one registry, maybe two registries. And pretty much, when we talk with people about scale, it was whether they want to secure their dev or the production. The problem was very easy to solve. Today, 4 years later, when we talk about scale, it's not only about the size. It's also about the complexity. We are seeing customers running on multiple clouds, right? We are seeing customers using multiple stacks, multiple orchestrators, multiple CI/CD, multiple registries. And when we talk with those customers, when they tell us we have a scale issue, it's not just about whether they have 500 or 5,000 nodes. It's more about whether they have one orchestrator, two orchestrators, or 3 clouds, right? And as the scales grow, the challenges grow. So let's talk about what are the challenges when talking about security at scale. First of all, who is managing the security? Do you know? It's an easy question when you have one deployment, one Docker, for a single team. But what do you do when you have 3 clouds, 5 different orchestrators, and 50 or 100 teams, right? Who manages security in that case? Second question. How do you do centrally management of security when you have so many orchestrators, clouds, and registries? How do you deploy security? Are you going to apply strict policies, meaning no one is allowed to run containers with high severity vulnerabilities. No one is even allowed to run medium severity vulnerabilities. Or whether you're going to find something that one size fits all. What's going to be the policy? And last question, maybe you shouldn't deal with scale. Maybe we should all go back 4 years ago and just use one cloud, one stack, and one CI/CD. Probably not. So before we dive into the solution, let's all remind ourselves, why do we all care about security? And I'll give some examples from the recent few weeks and a few months. So when you have scale challenges, when you have multiple orchestrators, multiple clouds, a lot of workloads running, you actually have a lot of blind spots. So you have attackers that can actually use those blind spots to get into your organizations. And let's have some examples. So the first one, something from 2 weeks ago. Have you heard about the Node.js vulnerability? Someone heard about it? Node.js, open source? Good. So this is a supply chain attack. What it means that there was an attacker that was able to take ownership on a GitHub repository. He was able to be the maintainer of that GitHub repository. And what the attacker did, he implemented code. He encoded the code inside of some kind of an encoding, and in that code, he was attacking crypto wallets, right? Now you have an open source project, very popular Node.js open source project, and everyone using that open source project is basically hosting an attack inside of its code, right? So think about it, when you have scale, when you have hundreds and thousands of projects, when you're using both Node.js, Go, Ruby, Java, you need to make sure that everything that you're using is legit. It's not an easy problem. The second thing, my favorite, Bitcoin mining. When you have one machine, it's easy to know whether you have a miner inside, right? But what about thousands of machines running on different clouds, on different orchestrators? It's not very easy to monitor the CPU and memory out of all of those environments, right? Maybe there is a workload out there, maybe there is a peak. You cannot know that there is a miner out there, right? And we know about companies that had miners for months, 6 months, and they didn't even know about it. And personally, what disturbs me, it's not the mining. It's not the fact that someone is taking your CPU and memory. What disturbs me is it's the issue that instead of a miner, it can be something else. It can be a command and control. It can be data exfiltration. It can be something in your organization that you don't know about. And the last thing, I couldn't resist, vulnerabilities. Last week, there was a vulnerability in Kubernetes, quite a critical one, a privilege elevation. And the challenge with scale and vulnerabilities, and not only vulnerabilities, but also making sure that you have secured configuration, is mostly around, do you really know where are your Kubernetes clusters that are vulnerable? And if you know, how much time would it take you to patch them, right? So the whole area of vulnerability management, patch management, and even knowing whether you have weaknesses in your configuration, it makes super challenging at scale. By the way, did you all patch the Kubernetes vulnerability? OK, if you didn't after this session, please go ahead and do that. So a lot of issues, a lot of problems concerning scale. Let me try to make some order and to try and explain what you should do. So at Aqua, what we did, we defined 4 levels of maturity, basically security maturity that we see in different organizations. The first one, it's very basic, very easy to implement. It's something called cluster hygiene. It basically means that you have now a Kubernetes cluster, and you run CIS, benchmark tests, you run vulnerability assessment, you run role-based access control, making sure that the hygiene there is OK, and you don't have issues with your cluster, right? Your kernel is up to date, your Kubernetes is up to date, and you are not allowing anonymous access to the API servers. So that's basic. You can easily do that. There are a lot of open source tools. You can use Aqua. And I assume most of you are doing that these days. The second level, image hygiene, what's known in the industry as vulnerability scanning. So in the image hygiene, what you need to do, you need to make sure that the images that you are running are free of vulnerabilities. There are no high severity, medium severity, and even low severity vulnerabilities inside of your image. I assume that you're applying vulnerability scanning into your images. You're probably also not allowing users to take images from public sources like Docker Hub without validating them first. And you probably have some kind of an assurance in the company only allowing developers to use baseline images that are approved. Once you have that, you sign every image, and you allow this image to run only if it's signed. Right? I'm still basic. The next one, what we called limiting the blast radius. Assume you've been attacked. Someone is inside of your container. What can you do? You can pray, or you can reduce the blast. Reducing the blast can be done by using sandboxing, gvisor, kata containers. They are all used to make sure that the attacker will not be able to use kernel exploits and then from the container get into the host. You can add authentication and encryption to the channels, right? Things like Istio, making sure that if an attacker is inside, the attacker will not be able to communicate with any other pod because he doesn't have the certificate to do that. And of course, you can limit the privileges. Make sure that you are running container not as root. And in that case, if someone is inside, this someone only has limited privileges, non-root privileges, basically. So limiting the radius. And the last one is preventing the attack. we all know that containers are immutable, right? So why not use that? Why do you allow new code to be injected into containers? Why do you allow to run new code into containers? Why do you allow new flows to be used inside of containers? If you will prevent that, you will prevent the attack. Okay, easy. I'm sure that after this session, you're all going to implement these controls in your companies. But in reality, what we have seen, it's not that easy. We've seen that organizations, they have multiple teams, and those teams will implement some of those controls. There are some teams that are more advanced, some teams that are more basic. Think about your online marketing campaign. They will start with cluster hygiene, while your online banking production servers will go all the way to the container prevention, to the runtime prevention, right? So in reality, one organization, one enterprise organization that's dealing with scale will have different implementations of security, different implementation of the maturity. So let's try to solve the problem. Now, we stated the problem, you know what you need to do, you know what are the controls. Let's try together to find out how you're going to implement the solution inside of your organization. So let's start with the easy. You know, I'm an engineer, I'm a developer. I always try to start with the easy solution, the one size fits all. Assume that you can do all of the security controls together. You can implement them in your company. Are you going to do that? Probably not, because you have different teams with different security needs. Like I said, you're not going to protect your online marketing the same way you're going to protect your online banking. And if you will do that, if you're going to add a lot of security controls and a lot of friction, what will happen is that the teams that do not need that, the teams that do not need that level of security, they will find ways to overcome it. They will find ways to disable the security because it might add some friction to their work, and they would like the freedom and the ability to choose whatever tools, whatever processes they need. So you cannot use one size fits all in a scalable organization. So let's talk about some more practical options for the scalable organizations. The one size fits most. So what does it mean? The one size fits most means that there is a default set of security that we can all agree upon. It can be we are not allowing to run vulnerabilities, high severity vulnerabilities. We are applying some of the CIS security checks. And we are encrypting the traffic. Each organization might have its own default set of security controls. And then, once you have that, you need to have a centrally managed approach to apply those security controls across the organization. Once you did that, what's left is to make sure that if you have certain needs for certain groups, like the online banking group, you might need more controls. So you need the ability to give certain groups the freedom to add more security because they have more sensitive data, because they have more regulations, or whatever, what are the cases, right? So let's talk about that. Let's talk about the one size fit most. How do you do that? And here I present a model, the centralized, decentralized model for security. I invented that. It's a good name. It's not a good name? Okay. I'm taking the credit on that. At least for Kubernetes, I invented that. So what is it? What is the centralized, decentralized concept? It means that you have a centralized team. It can be your global security team that will define the best practices, that will define the common security across the organization. And then you see those spikes, you see those Kubernetes clusters in the diagram. You have teams implementing Kubernetes, running Kubernetes clusters. Each team will inherit the security policies from the central team, meaning the vulnerability scanning, the CIS, everything that is common. And then each team can apply additional security controls as they need. Now, you're probably nodding your head, but you're telling me that's too complex. Now I need to manage security, but I also need to educate all of the teams so they need to manage security for me. It's going to be complex. It's not easy, right? And you're right. It's not easy. So let's see what you can do in order to make it easier. Second thing I'm presenting, and this is something I invented, it's BIOP, bring your own pipeline. The most organized, not organized, but the most advanced organizations that we are working with, they have a team that is building a framework. This framework is something that allows self-service of orchestrator, self-service of creating CI/CD, and self-service of security. So think about a situation. You want to run OpenShift on Amazon, and you want to have, I don't know, encryption of workloads, and encryption of communication. So instead of your team building this setup, you go to a self-service portal, you log into the portal, and then you say, I want OpenShift on Amazon with encryption between the containers. You click submit, and in 5 minutes, you have it running, everything is set up, you don't need to know anything about security, you don't need to know anything about how to set up this environment, and it's already connected to the central control plane. So basically, you get all of the default policies, but you can also add additional requirements. And like I said, some of the most advanced organizations we are working with, they have this portal, they have this BIOP, they bring your own pipeline, and that's how they manage their organization. When you think about it, it's brilliant. It allows them to decentralize the work. So basically, it's a shared responsibility. It means that the security team is responsible for the governance and responsible for maintaining this system, but the actual local teams are responsible for implementing and running the security. Make sense? Okay, and this is how it all ties together. This is a blueprint for Kubernetes security at scale. So at Aqua, you see at the top, there is the control plane. We call it at Aqua, we call it the tenant manager. It's something that you can log into, and as a global security team, you can define the baseline security for the organization. You can define the vulnerability scanning, whether you want encryption, whether you want anomaly detection and container immutability. And after you do that, and I have a nice animation for that, whoop, what will happen is that those security policies will be deployed across your Kubernetes clusters, and you don't need to deal with that anymore. And right now, you have 4 different clusters running on Amazon, Azure, Google, OpenShift, DCOS, Docker Swarm, doesn't matter. They will all have the same baseline security enforced. Now, what you do next, you give your local security teams, usually it will be the DevSecOps, to manage those local deployments. So they inherit the policies that they got from the global team. They cannot delete them. They cannot override them. What they can do, they can add additional security controls. To summarize, and I promised you will have all of the answers, and this is the slide that shows all of the answers. So after these sessions, when you will go home, you have a Kubernetes security scale issue that you want to fix. You start very simple. You start by defining what is the set of security controls that you want everyone to apply, right? After you do that, you need some central management to manage the security across your different clusters, different clouds, different deployments. Then you go to your DevSecOps teams and you tell them, okay, guys, we have the global security. It's the baseline for everything. Now you, DevSecOps, you're going to implement additional security controls based on risk and based where you need it. If you have time, you will build this BIOP, the bring your own pipeline, a self-service portal that automates the process of the creation of the clusters, the deployment of the clusters on Amazon, and the assembly of the security controls inside of the cluster based on the needs of your customers, your internal customers. And the last thing, maybe I will pause here, the shared responsibility model. So for the last 3 years, the industry is talking about shared responsibilities with regards to shift left. Shift left means that you want developers to do more work. You want developers to be responsible for security, right? I'm a developer. I've added a vulnerability inside of my package. I'm responsible for that. I need to fix it. And if I will not fix it, the build will fail. This is what is called the shift left. What we are adding today at KubeSec conference is the decentralized of the shared responsibility. What the decentralized means, it means that you have one global security team, but it is not responsible for everything. It will delegate responsibilities into the DevSecOps teams, and then the DevSecOps teams can add additional security controls, which means that now you have the perfect shared responsibility model. Thank you, everyone.